Hey, what's up? Eighth grade, Catlin here with help on lesson 16 for your homework this week. And so let's knock this thing out. Noah and Lynn are making paper cones to hold popcorn to hand out at parent math night. And they want the cones to hold 9 pi cubic inches of popcorn. What are two different possible values for the height h and radius r for these cones? Okay, so we need two numbers that would make this work. I think the best way to approach this would be using the tables that we've been doing in class. So let me see if I can make a table of this for you. So the table always started with either radius or diameter over at the side. I'm going to start with radius because the diameter doesn't really matter here. And then it would jump up to the area of that circle base. So I'll put the area of the base as if it was a circle. And then we would go from the area of the base to how tall the cone or the cylinder was. And then that would tell us, what the volume of let's start with cylinder first. So we'll just draw it. I think that'd be easier than writing it out. So like the volume of a cylinder. And then we graduated to doing the volume of the cone. So this was kind of our progression through, getting the volume and stacking it up and then finding the cone at the end. So if we know that we want this cone to hold 9 pi as far as how much popcorn it can hold. Now that's 9 times 3.14. That's going to be like 28 point something. We're not worried about the specifics. We just want to know, okay, this particular popcorn holder, which is going to look something like this, right? If it's going to look like this, we want it to be able to hold this much stuff. And so if we work backwards in here, we should be able to pick out some heights and radii, if you want to go plural there properly, then we want to work backwards and pick some numbers that work for us. Okay. So if this cone was made into a cylinder, and I think this is going to help us, if it was the same height, same radius, and we made it into a cylinder, then how much would that cylinder can hold if the cone only held 9 pi? We would have to multiply by 3 because we saw that it took 3 cones to fill up a cylinder. So that means that this would be 27 pi. And I like working with this number better because we can divide this by different heights and get areas of bases that we can then turn into radii. Okay. And what we're trying to do here is we're trying to think of heights that will divide evenly into 27 and give us outcomes of numbers that we could take the square root of because we don't want to get ugly radius numbers, right? So thinking of numbers that evenly go into 27, I automatically think of 1, 27, 3, and 9, right? So like if I divide this by 3 and make my height 3, that would give me an area base of 9 pi. And I like that choice because 9 is a perfect square. You can do 3 times 3 to get 9. And so the radius would have been 3. So I like this first one that I just came up with off the top of my head where I divided by the height of 3 because it goes evenly in 27. That's why I picked that. So that's one that we could have. We could have a height of 3 and a radius of 3. And that would give us a cone that has a volume of 9 pi. Okay. Now there's another one in here that works out really nice. And I'm going to show it to you. The way that I thought about this was, all right, I've got to divide by a number that evenly goes into this and gives me a number over here that has a perfect square root. And so if I pick 9, which a lot of you are probably thinking right now, that would put 3 pi here, but there's nothing you can multiply by itself and get 3 pi. So I'm not going to do that one. And I'm not going to divide by 1 because 27, once again, nothing times itself is 27. But if I do a cylinder that's 27 pi, another cone that's 9 pi, right? If I divide it by a height of 27, which is not very, it would be a very tiny cone. It would be like a really tiny cone that's super tall like this. It wouldn't make any sense, but it would have an area base that's super small and it would only be 1 pi. I like that one really good because 1 times 1 is 1, and that gives me a nice little radius. That's a whole number, and I don't have to do any weird square roots. That's why I like that one. So these are the two that I'm choosing. A radius of 3 and a height of 3 and a radius of 1 and a height of 27. They would all have 9 pi as their area for their volume, or I'm sorry, their volume for their cone. And those numbers come out really nice and whole. All right. And if you plug them into the formula for cone, 1/3 pi times r squared times height, if you put 1 and 27 in for r and h, and you put 3 and 3 in it for r and h, you will get 9 pi for the volume for both of them. And so they work. Those are the ones that I'm rolling with. I think the table was the best way to deduce that. Otherwise, that's a pretty tough little problem. See you guys.